So today's lecture is titled Verifying Trig Identities. So basically we're going into more proofs and trying to prove that identities are true. And so the general process, Ruhan, now is the time to take notes. The general process is that we're given an equation, and to show that it's true, we want to simplify the left side so that it equals the right side. So for instance, if we were trying to prove that 1 plus tangent squared equals secant squared, we already know this is true, but let's say for the sake of argument, let's try to prove this. We would have to simplify the left side such that it equals the right side. And so we would convert tangent probably into sine over cosine. So we would do 1 plus sine squared over cosine squared. So just simplifying the left side. And then probably convert this 1 into cosine squared over cosine squared to get the denominators to be the same. So cosine squared over cosine squared plus sine squared over cosine squared. And then you can combine the numerators because now the denominators have been made the same. And then we know that sine squared plus cosine squared is 1. And so this is just 1 over cosine squared, which is secant squared. And so that's how we would verify that this identity is true. We tried to simplify the left-hand side such that it equals the right-hand side. Or vice versa, maybe it's the right-hand side. Okay? So at this juncture, we also have to say something, which is that there are some things that are illegal when verifying identities. So one thing that's illegal is multiplying both sides by something. Okay, so let's say we were doing this. We started from that, and then we maybe convert it to this. So far, so good. We just rewrote tangent and secant in terms of sine and cosine. What would be illegal is if we multiply both sides by cosine. Okay, the textbook and WebAssign are quite particular about this. If you multiply both sides by something, essentially the logic is that you're assuming that the original equation is true if we're changing the values of both sides of the equations. And if we're assuming what we're setting out to prove, then we end up in a circular reasoning where that doesn't work, where we're assuming the thing that we're trying to prove when we're doing this kind of manipulation. So some things that are not allowed is multiplying both sides by something, dividing both sides by something, or subtracting both sides by something. In general, the idea is that anytime we change the value of either side of the equation, that's not allowed. Even if we're changing it by the same thing, it's not allowed. So the first rule is,
You can always simplify.
yeah, can only simplify, cannot change the value. Cannot change the value of left-hand side or right-hand side. Can only simplify. Okay. Any questions about that? Only simplification is allowed. Yeah, and so, pretty much that's all the information in this lesson, but really the hard part is knowing how to simplify things so that you make the left and right side equal to each other. Because there's really no algorithm for what you should do in every scenario. You kind of just have to know by intuition what you're supposed to do, and that's what takes practice. Okay, we're all taking notes. Yes? No classwork today. No classwork today. Because we had a quiz, right? Because we had a quiz, there's no classwork. It's just homework. Okay, let's do an example. Let's say we're trying to verify this identity. Okay, secant squared minus 1 over secant squared equals sine squared. So, generally, the idea is that you want to start with whichever side is more complicated and try to simplify that into the less complicated side, right? Because it's easier to simplify than it is to take something simple and turn it into something complicated, right? It's kind of like the second law of thermodynamics, right? You guys learned that, right, in science? Yeah. Entropy is always increasing, right? Okay, so the more complicated side is obviously the left side. So we want to try to turn that into the right side somehow. So the first step is usually always to look for some useful identities that we can make use of so that we can simplify things. And here, an obvious one that comes to mind is the 1 plus tangent squared equals secant squared, right? Which we have memorized dutifully as students. So that means that secant squared minus 1 is tangent squared, right? So that's a very easy thing to do first. So we want to always be on the lookout for how we can use these various identities like that. So that means we can simplify the left-hand side as tangent squared over secant squared. Okay? So something that would have been illegal would have been to multiply both sides by secant squared. That would have been illegal. Cannot change the value of either side. Okay, so we can keep going. Now a good step would be to convert both tangent and secant into sines and cosines. That's always a good thing to try in general. So this would be sine squared over cosine squared times cosine squared. Because when we're dividing by a secant squared, that's equivalent to multiplying by cosine squared because they are reciprocals, right? And so cosine and cosine will cancel, and we're left with just sine squared. And so we've successfully turned the left-hand side into the right-hand side. Okay, any questions?
So we're gonna have questions where it just gives you like a statement, you gotta determine whether it's true or not.
It's going to be true, you have to verify it. I'm not going to give you guys false statements.
So
That would be kind of evil. Because, how do you know it's false until you get them into the same thing? But, maybe you're just not done simplifying. So, yeah.
This is what you do.
I'm actually not very evil, so.
So like the whole thing is showing your work. Don't even
That's right.
give you the answer to this.
Mm-hmm. Any questions about this question? Next one. Okay, so try to use identities where possible, and then if you're feeling stuck, then just convert everything into sine and cosine, and things will probably cancel out. Let's do another one. Let's use more interesting variable names. Alpha. Okay, let's try to prove this. 2 secant squared alpha equals 1 over 1 minus sine alpha plus 1 over 1 plus sine alpha. Okay, which side is the more complicated one? Right side, obviously. Okay, so we have 2 fractions. A good first step is probably to combine the fractions. So we're going to write them as a common denominator. So that means multiplying the first fraction by 1 plus sine alpha, 1 plus sine alpha. Second fraction multiplied by 1 minus sine alpha. Right? i.e. cross multiplying. So this multiplication is obviously legal because we're just multiplying by 1, right? So there's no changing in value. And so the right-hand side is going to turn into 1 plus sine alpha plus 1 minus sine alpha all over 1 minus sine alpha times 1 plus sine alpha. Okay, the parentheses in the bottom are very important. If you don't have them, you're writing something that's incorrect. You guys have that habit of dropping parentheses. Okay, questions about that? We just turned it into one fraction. Okay, well, the top simplifies. The sign and the minus sign cancel out, and so we're just left with 2. But then the bottom, if we expand that, that's just a difference of squares, right? A minus b times a plus b. So this is going to turn into 1 minus sine squared alpha. Got it? But then 1 minus sine squared is just cosine squared. So this is 2 cosine squared alpha, 2 over cosine squared alpha, which is just 2 secant squared alpha. All right, so it's just algebra. Algebra. Questions?
Can you give us one to try?
Hmm?
Can you give us one to try?
You can do that on the homework. Any questions? All right, next one.
Wait, I didn't finish writing this.
Okay.
We'll do each other next time.
Okay. What should we do now? Gamma?
Wait, what?
Let's do gamma. We're going to know the entire Greek alphabet by the end of today. Alpha, beta, gamma, delta, epsilon, zeta, eta, theta. Okay, which side is the more complicated one?
Left side.
What's first? What are the identities you can use to simplify the left side?
Cosine squared minus 1 equals sine squared. Right?
Wrong.
Isn't it the cosine of,
Secant squared times, what is that? Sine squared? No, wait.
Drawing all that.
Sine squared. Oh, that's squared, so.
All right, so we have those two things memorized on the right side. 1 plus tangent squared, secant squared.
Secant squared times sine.
It's not sine squared, right? If we manipulate that second equation, this is cosine squared minus 1 equals minus sine squared. Right? Moving the 1 to the left side and sine squared to the right side. Got it? So that means we can simplify this expression as secant squared gamma times negative sine squared gamma equals negative tangent squared gamma. Okay? And then the next step is to simplify the left side by writing secant squared as 1 over cosine squared. So this is 1 over cosine squared gamma times negative sine squared gamma. And then sine over cosine is just tangent, so this is just negative tangent squared. And we're done. Any questions? We just use identities, converted things to sines and cosines, and then we get the answer. Okay, any questions? Too easy? All right, noted.
Test turns?
Let's do another one. What letter should we use now?
Sigma.
Yeah.
Sigma? Sigma is not commonly used as a variable. How about zeta? You guys know how to write zeta? Okay, I expect to see this in your notes, the zetas. Tangent zeta plus cotangent zeta
Okay, how do you draw that? This is
Just like a stumbling block to this point.
I'm just gonna draw it.
cosecant zeta times cosecant zeta.
Wait.
I'm drawing beta.
Right side's more complicated.
Do we get extra credit for drawing zeta in our test?
No. At least it's not a psi. Wait, that's wrong.
Ooh.
And the uppercase version is just x.
Kidding.
Okay, I think I'll use like an uppercase.
Wait, no. Uppercase is like this.
Oh, it's like Korean Chinese.
Mhm.
It's not really.
What do you mean not really?
Oh, that,
Yes,
yes.
Korean Chinese.
Yeah.
Okay, tangent plus cotangent equals secant times cosecant. So here, it doesn't seem like we can use any helpful identities. So a good first step to try when you're stuck is always to convert everything to sines and cosines. So we're going to convert the left side to sine zeta over cosine zeta plus cosine zeta over sine zeta. And then secant, what is that? That's just 1 over cosine, right? These are some beautiful zetas.
That's a fun letter to draw, isn't it?
It is. Looks like a little snake.
Just copy me.
Okay? So now this Alice provides some complications with which we can simplify into something interesting, right? So the left side, we can convert that into one single fraction. So if we kind of make it a common denominator, cross multiply, then this is just going to be sine squared zeta plus cosine squared zeta over sine zeta cosine zeta. And then the right side, we'll just leave it as that for now. Okay, questions? We just made it into one fraction. But sine squared plus cosine squared, that's just 1, right? And so this is really just sine zeta cosine zeta on the denominator. And we're done. It's the same as the right side.
Let me write all this down.
You need to write all of it.
Not a plus.
Maybe stay open.
What variable's next?
Beta?
Do a smiley face.
Oh yeah. At the beginning of the year, we did like apples and oranges, right? Bananas. Yeah, I did.
I do not remember that. Make up a letter.
Just use the uppercase side. I like that one.
No.
Let's do chi.
I?
That's a
Chi. Oh, lambda. Lambda's good. Lambda's good. Okay, any questions about this question though?
No.
All right, then. Next one's a hard one.
I got it.
Let's use a beta. Secant beta, that's disgusting, plus tangent beta equals cosine beta over 1 minus sine beta. Okay, so both of them seem kind of complicated, so we might have to simplify both sides in some way. But let's start with the left side. We're kind of stuck. We don't know any identities here. And so let's just convert everything to, no, right side is not 1 because 1 minus sine is not cosine. It's 1 minus sine squared, that's cosine squared. And then let's convert the left side to sines and cosines. Maybe that will help us. So secant is 1 over cosine. And then tangent is sine over cosine. Right? So that means the left-hand side is just 1 plus sine beta. Beta is really hard to write. Okay? 1 plus sine beta over cosine beta. And somehow we have to convert this into the right-hand side. Or maybe convert the right-hand side into the left-hand side. Any ideas? Unfortunately, we have to use a trick that we don't really know yet. And that trick is called multiplying by the conjugate. Cross multiplying is not allowed here,
Oh.
right? Because that would change the value of both sides. So the trick here is to multiply top and bottom by 1 plus sine beta. Do you guys see how this resembles the conjugate?
It's still one.
Right? So like back when we had to rationalize stuff like this, we would multiply by the conjugate, right? Multiply top and bottom by just change the minus sign to a plus sign or the plus sign to a minus sign. And that would effectively help you cancel things out. So in trig, there's a similar idea. Okay, so this is called multiplying by a quote-unquote conjugate. It's not really a conjugate, is it? So whenever we encounter a 1 minus sign, we can multiply top and bottom by 1 plus sign. Or if we had a 1 plus cosine, we could multiply top and bottom by 1 minus cosine. The reason why we want to do that is because we want to introduce a 1 minus sine squared or 1 minus cosine squared, right? If we do that, we know we can simplify stuff. So that's the idea. Here, if we multiply by 1 plus sine beta, that means that the bottom is going to turn into 1 minus sine squared because of the difference of squares, right? And so that's the idea. The top is going to become cosine beta times 1 plus sine beta. But the bottom is a difference of squares, right? A minus b times a plus b. So the bottom is actually 1 minus sine squared. But 1 minus sine squared is none other than cosine squared. Right? But cosine squared is going to cancel with the top and leave us with just with the cosine. And so this turns into 1 plus sine beta over cosine beta. And so we're done. So we had to use a clever trick there. So that's a trick that you guys should remember.
How many problems are in the classwork?
No classwork today.
Okay.
Thank you.
Are we done?
Nope. That was the second to last example.
Wait, I need to write all this down.
Okay, any questions? Multiplying by a conjugate.
Hey, bro, John, what are we at?
All right, next one.
Stop!
Okay, fine. Is here fine?
Wait, just stay here for a second. I need to write all this down.
Let me write the next question. What letter should we use?
Use sigma this time. Why not?
Okay, sigma.
Choose sigma.
No, I don't want to use sigma. Let's use delta.
How about kappa?
No. Kappa is not a commonly used one for these.
I'm just naming like. I'm just going off for fraternity names.
That's crazy.
What's this variable called, Mr. Matt?
Delta. See how it looks like a D?
I mean, delta's literally a... Delta's literally a triangle.
That's the capital delta. This is a lowercase delta. Okay? How shall we verify this? Well, both sides look very complicated, so we're probably going to have to simplify both sides so that they turn into the same thing. There are many different ways to do this. There are many different ways to do this. I'll show you the way the textbook does it. So the way the textbook does it is that they convert the cotangent squared into a cosine squared minus 1. Cosecant squared minus 1. Wow, I'm very jumbled up. Okay, so 1 plus cotangent squared is equal to cosecant squared, right? So that means that cotangent squared is equal to cosecant squared minus 1. So that's a substitution we can make. Okay, any questions there? Supposed to have some tails here. Well, cosecant squared minus 1, that's just a difference of squares. And so actually we can factor that as cosecant minus 1 times cosecant plus 1, which very helpfully cancels with the bottom, doesn't it? And so because these cosecant plus 1s cancel, we're actually just left with cosecant delta minus 1. Okay? Equals 1 minus sine delta over sine delta, the right-hand side. Got it? So we used an identity and then a clever factoring to cancel with the denominator. But then the right-hand side, actually, you can just split this into two fractions, right? This is just 1 over sine delta minus sine delta over sine delta, which is none other than cosine delta minus 1.
I'm just gonna snap a pic of this.
Okay.
Once you're done.
And so we're done.
It's on YouTube, I got this. I'm just gonna snap a pic of this.
Are these the question, are the test questions gonna be as hard as these questions?
Yeah, I think so.
Wait, no, he said?
What?
I think so, yes.
They will be as
Hear
hard?
that?
Any questions about this? The really hard part about these is that the steps are so simple, but the hard part is just knowing what to do. Yeah. Okay. So, just do your best. All right, I'll show you a different way of doing it. Okay, let's start with the original question again.
Which one would you say is easier? No, the textbook or the one you
Neither is considered easy.
It just depends on the person.
Yeah, I mean, both will get you the same answer. So this time, let's do what we did before, which was multiplying by the conjugate. So the left side, let's try multiplying both top and bottom by 1 minus cosine delta. Okay, so I have my original fraction, and then I'm going to multiply both top and bottom by 1 minus cosecant delta. That's what I meant to say. Okay? And let's see if that works. Any questions? Okay, well, the top is just going to turn into cotangent squared times 1 minus cosecant delta. And the bottom is a difference of squares, right? So that's going to be 1 minus cosecant squared delta. But 1 minus cosecant squared, we know something about that, right? If we use an identity, 1 plus cotangent squared is cosecant squared. So that means 1 minus cosecant squared is equal to negative cotangent squared. All right, we can recognize that identity. Questions about that? That's why it's so important to have them memorized. They need to be at the tip of your tongue. All right, so this is going to simplify to cotangent squared times 1 minus cosecant over negative cotangent squared, which is going to simplify, right? They cancel out on the top and the bottom. And so that becomes negative 1 minus cosecant, which is cosecant minus 1. And then we can do the same thing as before.
Minus cosecant?
What? Okay, so, you know, not trivial, but not impossible either. So, you know, in general, just try things that work. If things don't work, that's fine, just try something else. But the worst thing you can do is just stare at the paper and not do anything, right? That's true in life as well, you know, just try things.